This last problem is asking if n of -8 comma -15 is a point on the terminal side of theta in standard form. Find the exact values of the trigonomic functions of theta. Alright, so right away we're going to do Pythagorean theorem to find the last side of this triangle because we're going to need it to find the exact trigonomic values. And all we have to do is 8 squared plus 15 squared. So if we do that on the calculator, 8 squared plus 15 squared, we're going to get 289. But remember, we're going to have to square root that because we need to find the squared root. And so if we square root that value, square root this, we're going to get 17. So our third side is going to be 17 squared, or just 17 in terms of finding the trigonomic value. So now that we have that last side, we have to make sure we know what quadrant it is just to help us. So this is going to be in the third quadrant because there's two negative values here. So -8, -15, and then this last value is going to be +17. And to make it a little bit easier to view, I wrote again the triangle here but flipped over just to help in my brain. So x, this is going to be our terminal side, so everything is going to come from here. So the first value, sine, is going to be opposite over hypotenuse, which is -15, +17. So the entire thing stays negative. The cosine is going to be the adjacent over hypotenuse, which is -8, 17. And then the tangent is actually going to be +15/8 because it's a negative divided by a negative. So +15/8, which is the opposite over the adjacent. And then for these three values here, cosecant, secant, and cotangent, you would just flip what you have on this side. So the opposite of sine theta is going to be -17/15. The opposite of this is going to be -17/8. And then this is also going to stay +8/15.